So thank you very much for this introduction. I thank the organizers for providing me this opportunity to speak to you. I am very happy to speak before my Guru, Professor Y.K. Gupta, and my other colleagues, Vijay, Professor Akbar Shah, Dr. Idris, and others. I think the discussion tone has been already set by our President, Professor Y.K. Gupta, that so many dimensions have been spoken about by and the other speaker from Dr. Upendra from Indian Institute of Sciences. Yes, as Dr. Gupta mentioned, that every institute is working in so many other directions. So some kind of synergy, collaboration, consortium should be there. For example, our institute, Jamia Department of Toxicology, Medical Elemental and Toxicology, has also research program on alternatives, including the Drosophila model, and some sponsored projects are also under a young colleague, Professor Sohail Parvez, and zebra fish in my lab, and C. elegans is another model, and alternative in silico models, etc. At IITR also, Dr. D. Kar Chaudhary, who was the student of Dr. S.C. Lakhotia from Banaras Hindu University, established a huge research program on Drosophila melanogaster. I think Dr. Upendra must be familiar. So lots of leads are there from Kerala University, from CCMB, from the Trichapuri, the Trichy institutions. So somehow we have to do some kind of, that one institute, one specialization, or every specialization, but some kind of common brains should meet together, minds should meet together, so that we share experiences and knowledge with each other. So my talk will be focused on the technological interventions in the alternatives, toxicological models. The purpose of this talk is that how technology can help, this is working, to provide tools to the scientists, to the researchers, so that this is nowadays it's a word of technology. Everybody is talking about technology, machine learning, artificial intelligence. In everything there is intervention of technology, and we cannot live without technology. This is technology, mobile, and everything around, surrounded by technology. And now Alexa is there in most of the houses. So we give direction to the Alexa, and she or he, I don't know what gender she, but people have made its Alexa. Sounds female because we are a man-dominated society. So we look women as to do everything for man and for family, for house gods. So nobody has given name something like Alexander, but it's Alexa. So this is a bias in our society. So we think that only women will do for us. But I can see that more than 50%, 55, I think 60% audience is girls. So bravo here in this house. So next, shall I do this? Okay. So this is one that Dr. Upendra mentioned about science in a different way. He just thought that if something will appear in science, it will be acceptable and Nobel Prize will also be won. Dr. Gupta also mentioned one paper in Nature about the alternatives, and this is another article, small article appeared, written by Gayatri Badyanathan, who is the Indian correspondent, science correspondent. I think whether she is currently not or still there, about this concept of India pushes for alternatives to animals in the biomedical research. And I am very happy to share with you that the first conference of this alternative, in fact at that time even society was not formed, was held at our institution, Jamia Hamdard. We organized it, and it started a kind of movement. From there we moved to Bombay and to other places and this society was formed under the patronage of Professor Akbar Shah and many other like-minded people. So alternatives is there. And we Indians love animal, we even worship animals everywhere in all corners of our country, in one form or other form, in one animal or other animal is worshipped in a way that we care and we love. Even we put them in the places of God and goddesses also as animals. So, and then even that was the nature paper, and this is the paper. This is a news item, very lengthy news item, written in Financial Times, which is like Times magazine, which is equivalent to this Financial Times, not Indian one, published. So they also talked about how science is getting closer to a world without animal testing. So that way there is a movement, there is a kind of undercurrent about the alternative animal there in all over world, in our country as well, and I think slowly we will be having. India already banned dissections of the animals for undergraduate and postgraduate students, and they are pushing for animation or simulation models for dissections, and it is effective and it has been implemented. Nothing has happened, no results, and we are having similar quality of doctors and engineers or other allied health people, even pharmacists, without dissecting the animal. When I was a college student, I dissected frog and other animal, but now it is totally banned. So without animals also, we can produce the result, and we can produce the graduate, undergraduates, whatever we call. Now, I will be talking about these 3-4 aspects where technological intervention is there, and in some areas our laboratory and our department is also working, especially in the in silico model, biomarkers, and one of the papers published by us has the highest, about 700 citations on fish biomarkers we published long back in 2009. So, these biomarkers is one of the things which is coming as which has been there established as an alternative model. Then biosensors also are coming in a big way. Technological, information technology, organ on chip, Dr. Gupta and other I have already mentioned. And this is molecular docking, and this is whole genome sequencing and new gen sequencing. We are talking about a lot. So if we go one by one, this is very important statement given by Thomas Hartung. I think he will be connected to you in this conference from Johns Hopkins, and he is patronage of our society and also international advisor. I think he will be connecting with his wife sometime. We have program like that from Johns Hopkins and talk to you all directly. So he mentioned that about this, that can computer eliminate the animals? To some extent, yes, but like people like Dr. Gupta also mentioned that we have to have a balancing act, that both the sides have to come together. For certain extent, as a toxicologist, as a PhD, and also head of the Department of Toxicology department, and we are running MSc and BSc and undergraduate program in toxicology, PhD. So as a toxicologist, sometimes I am also in the doldrum state that what I should I promote or propagate 100% alternatives, or there has to be somehow somewhere use of animals as well. So we have to have a balancing act. We have to do a balancing act. We have to use in certain rare cases where there is no alternative. We have to use alternatives. Otherwise, our results will be delayed and they will be challenged from various corners. And also, if as Dr. Gupta mentioned, that if there is alternative, if there is testing has already been, what is need of repeating? LD50 is known for most of the chemicals which are on the earth. In most of the chemicals, we know the LD50. We know the LD10 also, we know the LD1 also, we know LD10. So every kind of lethal and as well as sublethal, subchronic, chronic, subchronic, toxic effects of all the chemicals, most of the chemicals which are on the earth, we know. So why to do that? Why to reinvent the wheel? So that is where if we question that why we need to do, why we need to repeat, we can always reduce the number of animals. So similarly, role of information technology is also very important in the sense that we should have very proper information. Professor Dr. Vijay Pal Singh is animal activist. He is also member of many animal ethics committee. He will often challenge the investigator that have you properly read that this is already, why you are using Wistar rat, why you are using Sprague Dolly rat, why you are using Swiss albino rat, mouse model. So generally information is sometimes missing. We are very excited as a researcher, as a young researcher, we want to do something, we want to do some dosing. Many times my students are very sad. I was having program on fish. So most of many theses, PhDs were produced on fish model. And one program was also on mammalian. So mammalian guys, they were getting immediate postdoctoral fellowship. So they were depressed. Fish people were depressed. Sir, we don't get postdoctoral fellowship positions in America because we have worked on fish. So I will change my animal model to mammalian model because they can get postdoctoral fellowship position abroad. Well, that is not good idea. Yeah, I have been in Korea and Japan. Fish people are very much preferred there. If you do research on fish or aquatic animal models, they will prefer you to be teacher, to be faculty, to be postdoctoral fellow in South Korea, in Japan, in Hong Kong, in Taiwan, countries including in those areas. So nothing, you have to have clear idea, you have to have all information, and that information technology intervention is very important. Different type of databases, different type of information resources, all are available, all you can access, and then you plan your research so that you don't have to reinvent the wheel. That is one of the most important thing which I observed, that even we don't review the research of our own institution sometimes, and our own country publications also. It was surprising to, even for me also, to know that Indian Institute of Sciences has such kind of program on zebrafish and Drosophila melanogaster, and no doubt Indian Institute of Sciences is one of the, in fact the premier and very topmost institution in ranking another way. So that is there. So information in technology has to help in all the way. Those who are in the field of toxicology, little bit whatever way they are conducting the experiment, they know that there are certain stages in the exposure to a toxic chemical and final outcome or toxicity, symptoms and pathologies which are observed. So starting from the external exposure to internal dosage, to the target exposure, to the interaction with the biological molecule, to the cell response, tissue organelle responses and population level responses. At each and every stages, technology intervention is there. Technology can be, if you have technology, you apply it and you will get better results, you can get validated results at each every steps. So, and then I have to even again emphasize that in case of regulatory agencies, industry, academic researcher, successful implementation of IT, information technology tools can yield a very good and validated results and acceptable results. Publication, you can target high impact factor journals, you can target reputed journals. That will be better statement that if you have all sorts of technological applications or uses in your things, and India is a technology technologically sound country, and many IT technology in particular have been developed in our country, so we should use all these tools in our research. Big data toxicology, that big data is nowadays a lot of talk about that, lot of courses being offered on big data, data science, so people are fascinated to opt for such a career. So in toxicology field also, we can apply big data. So big data is good because we have picture, or very big picture about the toxicological consequences of a chemical. We are not restricted to a certain type of population. We are not restricted to certain types of groups or age groups or gender group. We are having if big data, then we can have a very good picture. So 21st science century toxicology will be a complex, and we have to deal with big data. It is there in our mobile also. We sometimes have a lot of big data to compare, to contrast, to even we also use big data for purchasing something to compare to prices and other things using the big data. So in toxicology field also there will be a application of big data. So this is one of the flow chart published by Andreas Nichols in Big Data Predictive Toxicology paper, and he talked about they talked about the big data for toxicology. So various steps are there. So each and every step, I think here big data is a alternative to the animal models. You have big data, you have different types of databases, you have different types of toxicity levels and everything. So those big data can be now find their place. In medicine, big data is a big way. In toxicology field also, big data has to be used. Somebody can take research in those directions. A lot of opportunities are there. So benefits of broader and more diverse databases will be there, and by big data we can have a big picture. So like a borderless picture about the toxicological implications. We can predict emerging risk, complex exposure scenarios. We can address population variability, specific susceptibility to the toxic chemical by a specific risk group, and we can also group chemicals on basis of their chemical classes and toxicology classes, and we can also use in a very specific method. Similarly, artificial intelligence is also coming in a big way everywhere in our life, is affecting directly, indirectly, and we have to live with it, and toxicologists also have to look it as one of the alternatives for animal model. So we can see that how big way this from year 2050, when we talked about artificial intelligence, then Quasar came, quality structure activity relationship, then computer aided discovery came somewhere here, then docking experiments started in 1980s. So we can see that from year 2050 to 2010 data is there. So this level of this computer generation or efficiency is increasing. So accordingly, the big data, the artificial intelligence level is increasing. So this is how we can use these models, artificial intelligence in toxicology, drug safety and other things. So from here, starting from physical characteristics of the chemical to membrane transport to target binding, cellular responses, animal activity and efficacy and side effects, all this can be mapped using the artificial intelligence system, AI. Similarly, machine learning can also be a very good application in the toxicology field, especially in silico and in vivo, in vitro, all types of data. We can apply the machine learning ML techniques, and we can predict. And you can see that this is the one search for number of publications which have come from 1990 to 2018 using the two terms, that is toxicology, machine learning and toxicology is green. So you can see that slowly machine learning is also, people are researching, publishing paper and coming out of some research using machine learning tools and toxicology. This is PubMed search, where we can see that about 40 odd research papers were published using this machine learning in toxicology field. So I think we are 28, maybe it has increased more if we do new research. Quickly I will go. The technological advances in biomarkers is one of the aspects of toxicology which can have many technological interventions where this can be used. So biomarkers of different types of biomarkers of effect as well as biomarkers of exposure, we can apply different types of techniques and tools for more efficiency, for more accuracy and precision. This can be applied. So, how much time do you have?
Sir, time is over.
Acha, okay. Maybe 5 minutes can I take?
Okay.
So this is a disease and efficacy model. So quickly I will go. Then biosensors is another technology which is being used very well in detection and diagnosis of diseases, but also in the prediction and exposure checking and monitoring of the biosensor. So this is biosensor. I will quickly go, Dr. Vijayapal, showing only some pictures, and this is the classification how this one protein monitoring and biosensors can be used. Biosensor, nanobiosensor are nowadays a lot talked about. Organ on chip, I think many people will speak on this topic, including Dr. Mohan, and I will have some lecture on this aspect. He is also already doing that. So another, this is technological intervention for toxicologists, and I think it should come in a big way in India. And you are lucky that within Sri Chitra Institute, they have got a big project, even 3D printer also. So they are doing a lot of research in this. Young researchers can visit there, the toxicology division of the institution. So organ on chip. So quickly I will go, and I will not waste much time. Whole genome sequencing and next gen gene sequencing is another technological invention in the field of toxicology. So this is we are showing. We have also some program on this in our laboratory. So these are two slides now only. I think this is one Thomas Hartung I will again mention. These are two slides where you know that canaries, these birds were down in the mines in order to see the in British it was a routine practice where the caged canaries were down in the mines, coal mines, as a early warning signals. If they come out dead, then miners will not go inside because there are some toxic poisonous gases they might have been released from the mines. Later on, what happened that in DNA samples from one of the Haldane birds, using the modern, that same birds which died about maybe 1980s, it was banned. So about 42 years back, this DNA extracted using ECNGS technique, and it was correlated that it has mutagenic signatures of benzoypyrene there. So you can see that birds which died about 40 years back, more than 50 years back, the samples from, DNA sample from that bird was extracted, NGS technology was applied, and this was used, and it was found that those birds have mutagenic fingerprints caused by benzoypyrene. We all know that benzoypyrene binds with DNA, causes DNA deformation. So we can see that how old previous episodes and previous cases of toxicology can be verified, we can produce evidences that that tactics was used so long back, and application of NGS technology has enabled them to see that yes, it was because of that benzoypyrene. Benzoypyrene, those who are toxicologists, they know this is a carcinogen and mutagenic. So I would like to end my talk again. Our friend and friend of the society and friend of the alternative mission and vision and this movement, Thomas Hartung from Johns Hopkins, who said that an important milestone has been reached. Says Thomas Hartung, head of the Center for Alternatives to Animal Testing at Johns Hopkins in Baltimore, the first drug has entered clinical trials based only on data produced from organ on chip. So this was reported by Hannah Kuchler and Joe Miller in Financial Times in August 1422. So you can see that a drug has gone to clinical trial, which has been tested exclusively organ on chip. So there is a future for technology. There is a future for technology and toxicology mixing and intervention, marriage, whatever we call, and we need to work together. And technology can definitely lead to the reduction of animal uses in toxicology field. So thank you very much. I think young people are there. They can take up such kind of research.
Professor Raisuddin has created so many questions now. With lack of time, can we take only one or two questions? Okay, thank you.
I am here for 2 days, so we can talk and interact, and I am a professor, so I can speak for a whole day. Don't worry. Thank you very much.
Thank you, sir. And let me request Professor C.R. Patel, Department of Pharmacology, R.C. Patel Institute, to kindly hand over the token of appreciation to Professor Raisuddin.
Okay, thank you.
This is an honor for me.
Thank you, sir.
Yeah. Thank you.